In this question, I and j are horizontal unit vectors due east and due north respectively, and position vectors are given with respect to a fixed origin. A ship S is moving with constant velocity, minus 12I plus 7.5j kilometers per hour. Find the direction in which S is moving, giving your answer as a bearing. At time t hours after noon, the position vector of S is s kilometers. When t equals 0, S is 40I minus 6j. Write down S in terms of t. A fixed beacon B is at the point with position vector 7i plus 12.5j kilometers. Find the distance of S from B when t equals 3, and find the distance of S from B when S is due north of B. Okay, so I got the question here. I'm going to need to, this part here is missing. This should be t equals 3 here, so let me just put it in because it's not showing. When t equals 3, I'll put it here. Sorry about that. Okay, that should be t equals 3 there. So here's all the question then. The first thing is find the direction in which S is moving. This is the velocity of S. So we just need to find its direction then for part A. Let's have a look at that then. So we got minus 12i. I was due east, wasn't it? So this would be back this way. 12 units. And 7.5j is north. So we're going north 7.5. So there's the direction of velocity from this point here, which we can call the origin. And that's the direction. So the angle in question then, if we think about this as our frame of reference, is north. We're going around this much of an angle. So that's 90, 180, 270, and whatever this is. Let's label it alpha. So here, tan alpha is equal to the opposite, 7.5 over 12. So we just need to work out alpha. Let's type it in the calculator then. Inverse tan of 7.5 over 12. 32.00, so it's 32 degrees to the nearest degree. So answer then is equal to, well, we've come around 90, 180, 270 and 32 more, so it's a bearing of 302 degrees. So that's part A. Okay, so we've done that then. At time t hours after noon, the position vector of S is S, that's the position in general. When t is 0, S is 40i minus 6j. So the velocity of S is this, so let's write that down. So the velocity is equal to minus 12i plus 7.5j, isn't it? And that's the velocity at t equals 0. The position vector S is equal to, let's write that down then, 40i minus 6j. There it is there, minus 6j. Okay, so let's integrate to get the position vector then. So here, S, integrate this with respect to t, minus 12ti plus 7.5 tj plus our constant of integration vector. So here, so when t is 0, S is 40i minus 6j, so put it in here, is equal to t is 0, 0i plus 0j plus k. So that tells us then what k is, the constant vector. 40i minus 6j. So that tells us then what S is in general then. Here it is here. So the k vector 40i minus 12t. So that's 40 minus 12t. Lots of I then. Put them together. It's easier on the I. And we've got 7.5t minus the 6 lots in the j direction. So there's our position vector then for s, which we've done. Okay, write down s in terms of t, which we've done. A fixed beacon B is at this position. Find the distance of s from B when t is 3. So 7i plus 12.5j. So B at 7i plus 12.5j. Just going to go back up and double check that. There it is there, 7i plus 12.5j. Part C, find the distance when t equals 3. So s when t equals 3, put it in here, 40 minus 12 3s are 36, 40 minus 36 is 4. 7.5, put t is 3 in, 7.5 times 3 minus 6, 7.5 times 3 minus the 6 is equal to 16.5. So the distance then between this, so answer then, well, square root, use Pythag, the difference between the sides, 7 minus 4 is 3, and 12.5 minus 16.5 is a difference of 4. So those are the two sides of the triangle. So when we tap that in the calculator, we'll see the longest side. The distance between those 2 points is 5, and the units are kilometers. So there's part C. Now part D then. Find the distance of S from B when S is due north of B. So when S is due north, so here, to be due north, the y component, the x component must be 7i. So this s, 40 minus 12t, must equal 7, mustn't it? Because this is the x component, this is the x component, and then they'll be on the same x value, so to speak. So that tells us then that 12t. So I move the 12t over here, move the 7 over, 40 minus 7 is 33. So t is equal to 33 over 12. Divide by 3, 11 over 4. Type that in a calculator if you need to. It's 2.75, isn't it? 2 3/4. So that's the time, hours, because we're measuring time in hours, aren't we? 2 3/4 hours. Okay, so that's the time. And then what did the question actually ask for then? Find the distance of S from B when S is due north of B. Well, we found the time, so we can find the coordinates now. So we found out when they have the same x coordinates, so distance, so answer then will be the difference in the, that was when the x coordinates were the same, so the distance will be just the difference between the y coordinates. So it's the difference, so it'll be the modulus, 7.5 times time, 11 over 4. Okay, minus 6, that value. Take away the value at B, minus 12.5. Okay, that looks like what we get here. So let's tap that in the calculator then, 7.5 times 11 over 4 minus 6 minus 12.5. And we want the modulus, 17 over 8, which is 2 1/8. And that's the distance, kilometers. And that was part D. Let's just double check. Find the distance of S from B when S is due north of P, which we've done. So it's just the difference between the y coordinates components when the x's are the same.